Okay, so officially welcome to the fifth Adeva Insights session. Today we have Ivan Jovanovic with us. He's JavaScript React developer working remotely for over 10 years. He has been digging into different things, different JavaScript concepts. And today he will talk about how to do reactive programming in JavaScript, because apparently React is not reactive. So Ivan, the stage is yours. Go ahead.
Oh yeah, thanks a lot. So yeah, everyone, thanks a lot for joining. This is actually my first webinar that I'm giving. And yeah, in the past, I did around 20-30 conferences, and this is actually the first talk I ever gave. And again, this is the first webinar with the same topic that I will be giving. So I hope that you will like it. So yeah, I'm going to talk about reactive programming in JavaScript and show you some, show you how it works, what are the pros and cons, and yeah, how I got here. So how I first started working with reactive programming. So yeah, why I created this talk at the start. So yeah, as once upon a time, I was working with a company that's creating some analytic tooling. So we had to build a new product that will get data in a real time from 30 different places, and it had to display everything in a real time, and that was really a challenge. So yeah, I started writing code, starting figuring things out, and yeah, I was sad and alone trying to understand how can we create something that's really fast and performant at the same time. And yeah, one day I had this situation where I finally figured out what's the thing that we need to use, and yeah, that was reactive programming. So we started with the project and we finished it. I was really impressed how everything worked fine with this new paradigm, and the whole team was really happy, and also the client. So after that, I wanted to share that with the world. So I worked with SidePoint and wrote this article on their website called "Why Am I Switching from React to Cycle.js?" And basically, it had a catchy title, but it was same as this talk. So it was more about the reactive programming, and since the React.js is the most popular framework, they thought that talking about React.js first and then some reactive framework, some alternative that's reactive would be really nice. And yeah, this article got very popular. So it was translated into multiple languages like Russian and even Chinese. So I was really happy to see this. And then one day I came to the first article, so on the SidePoint, and checked out the comments, and people came there either to fight because the React.js is the best the best framework in the world, or some other went there to read the comments and eat the popcorn, and people didn't really see the point of the article. So I wasn't there to argue. I was just there to explain stuff. And yeah, so that made me really sad, and this is why I created this talk, to change stuff and to show you really what reactive programming is without any fight. So yeah, what is reactive programming? The start. So I have this. So I got this from found from Anders Staltz. He's a really cool guy, and he's writing a lot about reactive programming. So you can find him online and check his work. And he said that, sorry, he's saying that reactive programming is programming with asynchronous data streams, and I really like this. So so from this, we need to see what is a data stream. So that's the main point of the reactive programming, and found this on Wikipedia. So it's data stream is just an endless sequence of digital signals. So we have some sequence, and there are some digital signals or data packets. So some data inside. How does that look like? So this is one data stream. So we have this digital signal that's endless, and then we are sending some data there. So starting from 60 to 10. So first, like, we have 60, 50, 40, 30, 20, and then 10. So in JavaScript, reactive programming is just the abstraction of all async processes into the data streams. So we now saw what's the data stream. Imagine that anything that's async, starting from like WebSockets, HTTP connection, or anything like that, that we handle asynchronously in JavaScript, can be abstracted into the same methodology. So you will use the same methodology and same code for everything async in your application, and that's really cool. So here's an example. How can we use some simple functions to work with data stream? So like, imagine that user comes to your website and he has to click somewhere a couple times. So he like comes to a div and then clicks 3 times. So each of those, so in the first data stream at the top, each of those blue circles is like one click. So he clicks first 3 times, then he waits, clicks again 2 times, and waits and clicks again. So we can create a buffer from each of those clicks that happen in the 500 milliseconds, and then we can create a packet of more or equal than 2. And this is like simple example. How can we think in the reactive way, and how can we see the data differently? So like, you saw like an example now. So why do I need this reactive thing? That's probably the thing that you're asking me now. So there are a couple things here. First thing is external service calls. So if you have a web app, you will definitely have some external calls, like only using WebSockets or HTTP connection to get some data from the backend or anything else. With this, we can create with reactive programming, we can create a abstraction of all those calls and use the same code for that. Then better performance. So as I said at the start, I started first with reactive programming paradigm just because I saw that it's giving you really good performance to work with, because everything is a data stream, and then you use just pure functions to work with the code. So there is no like classes, instances, or anything like that, like filling up the memory, and really makes your app like work fast. The next thing is like, it's highly testable. So it's really easy to test pure functions. So you can like create stream, put that inside your function, and then see what's going to be returned from the function. So you can test anything. As I said, you need to create like instances, mock stuff, and so on. Then it will give you an ability to abstract everything. So anything that's async will be managed with the same code. Then you can create predictable and extendable code. So like, just from reading the code, anyone will understand what's happening, and you can predict from it, and then it's extendable. So like, pure functions are used in the reactive programming. So you can create a function, then use it in some other, and you can really easily extend the whole thing without like using third-party libraries, or without like messing up the whole code and using any other paradigm here. So like, if you ever worked with or read about reactive programming, you probably saw word observable, and observable is the official terminology for the stream. It's like the same thing. Like, if you say observable, that's exactly the same as a stream. And then we have the observer. So observer is something that subscribes to observable and reacts to whatever item or sequence of items are inside the observable. So the observable emits. So it just some piece of code or something in your app that's listening to a specific stream and reacting whenever something goes into the stream. So reactive programming in JavaScript. So what libraries do we have here and what are the most popular? So we have RxJS. So you probably, if you're working with different languages, you probably saw like RxJava, RxRuby, RxPHP, I guess, RxPython. So that's the most popular and the biggest library. And the whole thing here is that if you work with RxJava, for example, you will use the same API, so the same functions, so the same naming of the functions in JavaScript now, and it's really easy to like migrate. Then there is Most.js, so it has the best performance, and yeah, if you check it out on their GitHub page, you will see that it's really fast. Then there is Bacon.js, and there is Xstream. So I think it's the smallest, so it has like not that many. Like the RxJS is probably the biggest, and it has a function for everything. Xstream is like the smallest, and it has just enough that you need for the start. And yeah, it's like, since it's the smallest, you will put the smallest amount of code into your app. So like compiling time will be faster. Now, yeah, so now React.js. So like people think that since the React sounds like reactive programming, they think that React is like reactive from the start, but it's not really. So let's see what are the React cons when it comes to working with reactive programming. So it's first is the data flow. So when they created React, they didn't really have that data flow in mind, and that's what I found really online. Then people started like working with React, and they started fixing that data flow issue with creating Redux or any other third-party library that you need to put in to have like simple data flow. Then like side effects. So it's not that easy to like jump into the React app from scratch and then have like some simple way to work with anything that's coming from the side, like HTTP or WebSockets. You again need some third-party library. And functional programming. So yeah, to be honest, that's being fixed right now. So we started like with hooks and just like pure functions for the components, and that's great. But from the start, it was using classes and like instances, and that was really a con for the reactive programming, because it requires pure functions. So yeah, for working with reactive programming in React, we can do something like this. So we can use RxJS and connect it with React, and like pull in everything that RxJS gives us. But it's not that easy. We again need something in between, like Redux. So if we want to work with RxJS, there are a bunch of libraries that help connecting Redux with RxJS, and then you have like 3 things here that need plugins in the middle that will help us to work with them. And that's okay, like this is possible, but like working with reactive programming in React is not that trivial. So again, as you saw in the article, there is a solution for this. So if you want to go with a different framework, there is Cycle.js. So I'd like to talk more now about the Cycle.js and how it helps us to create reactive applications. And from the Cycle.js official website, we can see that Cycle.js is a functional and reactive JavaScript framework for predictable code. This framework is created by Anders Stout, so the guy that I mentioned at the start with that definition about reactive programming. And think here, the React.js cons for reactive programming are Cycle.js Pros. So it's the same thing, like data flow in Cycle.js is really nicely handled. So it's built with data flow in mind. And from scratch. It gives you ability to create simple data flow through your app. And since it's using streams, you can easily create observers of that data flow that will re-render and react whenever something happens in the data flow. So side effects, yeah, it comes with a bunch of things that will help us to a bunch of plugins and like core code that helps us handle any side effect that's happening around the app. And also functional programming. So like from the start, Cycle.js is using functional programming paradigm where we have everything as a function, as a pure function. So just like input and output in the function, and yeah, right, nothing else is there. Features of Cycle.js. First thing is, as I said, it's just pure functions. So it's purely functional, and you don't need classes or anything like that. It's reactive, so reactive from the start. You don't need any library to put in. So it's testable. As I said, pure functions are really easy to test. And it's composable. So when you have pure functions, you can compose them one inside another and then create something bigger. And that's basically how Cycle.js works. So every component is just a function that we compose one inside the other. And it has explicit data flow. So data flow is just one big stream, and everything connects into that data stream. And it's made for large code bases. So like, as I said, we can create just the simple files with functions inside, and that's all. So you can easily manage a lot of features in your app just by creating more files and connecting them to the core. So how does the Cycle.js work? So here we have an example. The main, so that's the pure function. So that's our main function that will be used for rendering the app. And then we have sinks. So sinks are something that main function is returning. So we are returning everything back to the side effects. So if you're using DOM side effects, HTTP side effects, or anything else. And then we have sources. So those are the things that go inside our main function. So like if we have HTTP side effects, those will go in our app. Something will happen here. So we have pure data flow inside the app. And then we'll have sinks. So those things will be returned. Like if we are listening for some HTTP event, we can also return stuff back to the backend, for example, using sinks. So the data is just flowing around from the side effects to the main function and so on. So circling around. And this is like the only thing that's coming in the Cycle.js core. So we have this run function, and that's used to bootstrap everything. So we first pass the app. So that's our main function. And we pass the list of drivers. So drivers are used to handle all those side effects. And this is a list of drivers that we have. So we have like HTTP driver, DOM driver, WebSockets, local storage driver, HTML5 notification driver, and so on. So if there's no driver created by the Cycle.js core team, it's probably created and open sourced by anyone else. So there are a lot of drivers, and it's really easy to create your own if you have some other side effect that you want to use that's not created as a driver. You can easily create it. So we have a lot of packages coming with the Cycle.js. So first one is DOM. So it's collection of drivers that work with DOM. So it's based on the SnapDOM virtual DOM library, and it's used like to render stuff inside the DOM and also to listen for events that are coming back from the DOM. We have the history package. So it's a driver for the history API. We have HTTP, so driver for HTTP requests, and it's using super agents, so just a wrapper around it. We have isolate, so it's a really nice function that helps us isolate the function to create like scope data flow components. And then we have three run functions. So like for Cycle.js, it's like created in a really nice way where the reactive library is not coming with it. So you can use whatever you want. If you want to use Xstream, so the Cycle.js is created from the same team that created Xstream, and they recommend using Xstream. That's why the core run function works natively with the Xstream. If you want to use Mode.js, you can use most run. If you want something bigger like RxJS, you can use RxJS run to like connect with RxJS and use all the function that it provides. Probably if you want to use Bacon.js or anything else, there's probably a package that allows that implements the run function to work with it. And also, since like working with pure functions is nice, but when you have to put a lot of things inside it, it's not as nice anymore. So they created a model view intent paradigm. So it's when you have source and sink and you have things inside the main, it's like split up into intent, model, and view. So intent is used, so that's piece of code where you put stuff that will like parse anything that comes coming from the source. Like if you have HTTP requests, a bunch of them will come into your function, and you can like pick up what you need. Then model is used to prepare data and to do the calculation that you need to do the business logic. And then the view is used to prepare the data stream that will be returned in sync. And yeah, now let me show you a simple demo. So whenever you learn about new framework or new language, simple counter app is the simplest way to show how that works. So like this is a simple design. It just has two buttons. It has the counter label with 0 at the start, and then when you click on increment, it will do a +1. If you click decrement, it will do -1. And here is the example of this. So this is so like 28 lines that we need to create this. And yeah, so in the top we see like some imports. So we need to import Xstream. We are importing run from Cycle run, and we are importing some things from the DOM driver. So we import div, button, paragraph, and we import MacDOM driver that will be used to initialize the driver. So let's zoom in and see what our main function has. So it has like first part is intent, second part is model, and third part is creating virtual DOM. So view, so creating a view in the function. And intent here is looking like this. So yeah, it's like a standard. Whenever you have a variable that is a data stream, you put the $sign after the name, so action and then $sign, and that means that that variable is a data stream. So we use Xstream to merge events that are coming from the decrement and increment buttons. So here we use sources, so DOM source, and we're selecting from that. So from the DOM data stream, we're selecting decrement and increment events. So we're listening for clicks on them, and then we are mapping through every buffer. So we will have like data package, so just like a buffer with not much inside. So we basically have the event inside, and then we map each of those events into -1 or +1. So we want to easily work with numbers. Then we're using fold. So this is the model where we like do the business logic. So we want to create. So we have like accumulated data, and then we want to do accumulated data plus X. So that's the current value, and fold is like reduce. So we are like reducing this data stream into one number. So if the like accumulated data is like 1, if you click on increment, it will become 2, and so on. And inside the count variable, that's where we store data stream with where the last element is our final result. And then when we have the count, we can map through the count. So we will have like 1, 2, 3, 4 inside the count for each of those elements. So inside the data stream, we want to map through that and replace that with a div that has 2 buttons and 1 paragraph. And we want to show that number inside the paragraph, and we render those 2 buttons. And we need to return those 2. We need to return that as a DOM inside the object. And you see here, let me move back. So here in the first, we use the run function after the main, so the bottom, where the first element, so the first argument inside the function is the main function, and then we pass an object of with DOM, where we use this make DOM driver function that just tells us to listen for events that will be coming from the div with ID main. And then we need to return exactly the same thing. So you see on line 22, we need to return things in back to the DOM. If we had, like, for example, we can also have like HTTP. So we will do the same thing inside the run function. We will create a HTTP driver, and then we need to return things back to it so data can flow in the circle. So this is GIF, like it just showing you how that works, and it's really simple. So like with 28 lines, we were able to create something like this. Then how CSS works, we can like use, we can create a style object, put whatever CSS we want inside. And then step DOM is accepting a second argument. We can put object inside with a style property, and in that way we can style our components. Also, the Cycle.js is accepting JSX, so but it has to be installed as a third-party library. So if we want to use JSX, we can put it in and use that instead of this. So yeah, sorry. So handling HTTP requests. Again, simple example. How can we handle HTTP requests? So here instead, so with the DOM driver, we need to import HTTP driver. So line 4, make HTTP driver, and then at the bottom inside the run function, we need to initialize the HTTP driver. Sorry. And then inside our main function, we have different parts. So the first part is creating that request. Here we have some backend running on a local host, and we want to hit it and get some data. So we want to send GET request and get some data back. And here we say that we want periodically, so we want to create a new data stream, and we want periodically to put one buffer inside it, so every second, and that buffer should contain the URL and the category. So the URL is the location of the episode of the backend of the API, and then we have category. So it's important to put category inside this object, because HTTP driver will give us all requests that's going to happen in our app. So even like CSS or anything like that our app is requesting, that will go through our app. So it's important to have this category so we can filter only requests that we need. And then here we create a virtual DOM. So it's like, as you see here, sources.htp. So we are listening for HTTP objects inside the data stream, and we're selecting only ones with the category API. So we need to flatten that, because there will be multiple data streams, as I said, coming from different places. And then we map through it. So we take out the body. We have the start with. So when the data stream is empty, we create one object inside with the response that's empty string, just in case it don't fail. And then we map through that again, and we create div with some H2 element. and we show the response from the server. Again, we need to return the DOM and HTTP stream. So in this way, we are working with HTTP requests. So we are listening for something, and then we need to return things back. Now working with components, so we saw how to work with Cycle.js in general. We did this one main function, so one main component. To work with components, we want to create something like this. So we have one main function and then multiple smaller inside, and we want those sources to be passed inside those smaller functions in. So we work with the isolate function, and it's really nice because it helps us to isolate the component from other things and just pass the sources that we need in. So like we import some component and we initialize child component, and then we use isolate to pass just the sources that we need. Like we just want to pass DOM source inside this component because it doesn't need WebSockets or HTTP. And then we can use we can extract, so take streams out of our component. Like this child component is returning DOM, so we need it, and it can return any value or anything like that. So any calculation that child component wants to return, we can take that, and then we have like child component virtual DOM and value streams. We can work with them and then move that on. So a simple way to use components here, and then our main function can create those isolated components, and they can pass some data to them and wait for data to be returned. So those were some examples. Let's see what are the cons of Cycle.js, because it's not perfect, of course. So the first problem is community. It's not that popular, and there are a lot of things to be created. The community is not that active because companies are not using it like React or Angular, but it's moving on. So it's like every day, like someone starts to use Cycle.js and starts to contribute. So it's moving, and that's a really good thing. And then learning new paradigms. So reactive programming is not easy. So it has a lot of things. You need to switch your mind to a different kind of thinking. Like we're using the declarative programming, it's a bit different from it. So you need thinking in data flows, and it can be problematic at the start, but you will fall in love with it later. And yeah, some apps don't need to be reactive. Like you don't need to use reactive programming all the time. Like you can still use declarative programming in many places, and people tend to like put things and over engineer stuff, and Cycle.js will help you to do that, but it will be like too complicated. So yeah, some apps don't need this. Yeah, almost done here. So what's the conclusion here? We have the old paradigm with the new usage. I've read somewhere that like people were thinking about reactive programming even in 90s. So so it's not that new, but we're using it now in a bit different way to help us abstract stuff. It's not for everyone. As I said, it's a lot of times you won't need reactive programming to solve problems. It's like perfect for real-time applications that require high performance. So that's my experience, and it really helped us. Then it's testable and predictable code, and of course you will have one interface for all async processes, and yeah, that's really awesome. So what's next? Yeah, if you like Cycle.js and if you want to learn more, you can go to cyclejs.org and find some cool documentation there. You can see like getting started. There is even like create cycle app that will help you to start with it and create something. If you want to start with reactive programming, like in general, there's RJS Marble's really cool website where you can play with all, I think almost all methods. Probably they didn't document all of them. So like most of the methods are there, and you can use those interactive diagrams to play with them and then explore what each of those function is doing, like merge example here. So you can move those circles, and in the real time you will see what's going to happen. It's really nice to learn, and also to use it. Like when you start working, you can always jump back to that and see like explanation of that function. This is like some cool thing, like what I saw like a couple of years ago. Someone used the Cycle.js to view like real-time satellite test data. So he created some device that was able to communicate with satellite and take some data from it, and then he created a dashboard using Cycle.js that was communicating with the satellite in real time, and that's really cool. Like really cool usage of reactive programming. And yeah, thank you. So that was all. If you I'm occasionally writing on my blog, so if you want to see things like this, yeah, you can visit, and you can find me on Twitter. Yeah.
Perfect. Thank you, Ivan. This was amazing. We have a couple of questions related to what you talked about. So first, in terms of, you said it's not for everyone, it's not for every use case. So we have a question exactly on that. What kind of application do you believe that reactive will be better to use? And what kind of application is not better to use?
Like, yeah, so like I think anything that's working a lot, so that has a lot of business logic inside, I think it's really cool. Like if you're creating some dashboard, like for example Stripe, that will show you a lot of data there, you have a lot of functionalities there. I think the reactive programming is a really cool use case for that. Or even like if you have different side effects, like you have an app that's like has, for example, chat on it that's using like WebSockets, and then you have some graphs on it and so on with HTTP requests. It's really cool because you can abstract all those side effects into one paradigm. So you will use the same code like RJS to handle WebSockets and HTTP requests, and it will make like your life simple, because you will use the same paradigm to test your code and abstract everything. And like when you create something simple, like with couple HTTP requests, or like you create like I don't know, like e-commerce app or something like that, you probably don't want to use reactive programming because it will be over engineering. So like for here, I was using reactive programming mainly for some dashboards and analytic stuff, and it really like saved my life.
I guess it's mostly when you want to see it real time and have it update.
Oh yeah, it's really cool.
And I wanted to follow up on that because I know that you're working with React and you work with a lot of data heavy apps right now. Have you been implementing reactive programming with React? I know you mentioned at the beginning.
Oh yeah, like on one project that I'm working now, so it has like a lot of analytic stuff. It's using React. And yeah, it's using MobX. So MobX is like an alternative of Redux that gives us ability to work with data in a reactive way, and it's really cool. The performance is amazing because it's constantly sending some HTTP requests, and MobX is really able to handle that really easy, and like the code is not that complicated, so there's not a lot of boilerplate. So yeah, it's really nice.
That's great. So it's good to know that you can make it work, not that hard.
Yeah.
We have another question which is not that related to the topic, but it's more general about the JS community. So seeing Ivan is active in the JS community, what is the best approach for library creators to promote and push their libraries forward?
Not sure. Like I guess like writing. So there are a bunch of places where you can write and create tutorials like about your library. So whatever it's doing, like what I did, like, well, I like writing, so, and it helped me to like to share my knowledge with other people, and like those short tutorials are really nice. So something like that, like when someone can Google and explain the problem, make sure that like your blog post is somewhere in the top where people can find them, and that way I guess you will reach really the people that are trying to solve the problem that you solved with your library, I guess. Yeah.
You haven't tried it though.
No, I mean, I was like, I was helping a bunch of open source projects. I never created my own. So, but yeah, it's, I think like you created open source software to solve something. So if you can write about that, how it solved your problem, I guess people when Google that, they will be easy. I mean, they can find your solution, read about that, check your app, check your code, the library, maybe contribute, and yeah, it will just go like that.
Yeah, and speaking is another option there as well, like JS.
Oh yeah, of course, yeah.
Different events, meetups. So
yeah, definitely.
Contributing. Great. Well, we don't have any more questions. It was an amazing session. Thank you, Ivan.
Thank you.
This will go on our YouTube channel. So for everyone who didn't manage to watch this, they will be able to, or if you want to rewatch it and revisit some sections. Don't forget to subscribe if you haven't. We are having this every month, so we'll be coming up with something interesting next month as well. Thanks
even
again.
if you have more questions, like reach me on Twitter, on email, and yeah, I'll be more than happy to help. Thanks a lot.
Great. We get thanks from people in the attendees.
Oh, thank you.
Thanks everyone. Bye bye. Have a great evening, day.
Bye bye.